Welcome to another lesson, and this would be all about solvent leveling in organic chemistry. So, what is solvent leveling? This is just a phenomenon wherein you have a solvent. Ang ginahimo sa solvent is it would not allow any particular compound na mas basic or acidic pa kaysa sa iyang conjugate base or conjugate acid. So to explain this, for example, you have amide. This is actually a negatively charged. When you have an amide, which is a very strong base, and you have water as a solvent, the tendency would be like this is the solvent here, and this is the base. And of course, the solvent is the acid. The tendency would be these two would react together. The thing is, there will be transfer of protons because this is a proton transfer reaction. So ang product of this reaction would then be ammonia and hydroxide ion here. So this one is the conjugate acid of the base, and this one is the conjugate base of the acid here. Sila. So what is solvent leveling effect? Kaya siya nga phenomenon is ang solvent, dili gina siya musugot. Ang conjugate base sa solvent, dili gina siya musugot nga napay species nga mas basic pa sa iyaha. So, for example, you have an amide. Ang tendency when you have an amide in a water, na solvent, i-react gina ni water. Kaya kung dili na niya i-react, then of course there will be amide ions present in solution. And if such reaction happens, then na produce ng hydroxide ion because of course the hydroxide ion will be favored enough kaya mas stable man siya kaysa sa amide ion. Remember the lesson from the acids and bases, the atom that bears a charge would be the more acid. Kung mas electronegative siya, the more stabilized it is, so therefore the more acidic the corresponding acid is. So therefore the hydroxide ion mas stable siya, so it is highly favored compared to the amide ion. I-counter siya ni solvent para si amide, which is a very strong base, dili siya exist in solution. Kaya gusto ni solvent nga kung mahimo magay siyang conjugate base, wala na mas labaw pang mas basic kaysa sa iyang conjugate base. Okay? So, in solution, when they react together in the solution, si OH yun ang mas basic compared kay amide. Okay? Ammonia is pretty much less basic than hydroxide ion. You can check it out, the pKa values of the two. OH would always have the lowest pKa than ammonia. No, sorry. The highest pKa than ammonia itself. Mas basic is the hydroxide ion. And the solvent would not allow for a strong base nga mo exist in solution. Mo nang react siya to only allow itself. Especially in particular like its conjugate base nga maura gid siya ang mas basic. Dili gina niya allow nga napay mas malabaw kaysa sa iyaha, if you put it that way. So that's solvent leveling. Mo na nga when you have a strong base like sodium amide, for example, this is a very strong base. You should not use water as a solvent because of the solvent leveling effect. Mo na nga when you want to deprotonate something and you have water as a solvent, dili na mo take effect, dili effective when you want to do deprotonation of something. Kay males naman ang basicity aning sodium amide because of the solvent leveling effect. So that's the crucial part. That's one thing that you need to consider uh, when you do synthesis, for example. I-consider yun na mo which solvent ang imong gamiton. Okay, so that is why when you have sodium amide, you just use, for example, so you have an amide ion, which is basic. Ang tendency is, to solve that problem, nga mas mo render pa ang effect ni amine ion sa imong reaction, you just use ammonia, for example. And of course, this is the base. And you treat the solvent as the acid. See, the base, of course, it will disconjugate plus. Okay, so this will be the conjugate acid of the base, and this is the conjugate base of the acid, diba? Kung magamit kag ammonia, when you have a strong base, just like sodium amide, for example, the best choice to use as a solvent would be ammonia. Kay mo dominant ra Japon ang naara Japon kay amide ion in solution because kani si ammonia, when you deprotonate this one, this will just convert into the amide ion here. Just the amide. So that's the technique that this is actually a technique na pwede nyo magamit when you do reactions. So when you have a strong base, be careful about solvent leveling effect. You just amide, for example, just use ammonia as a solvent when you do reaction by using amide as a base, so that dili mawala ang purpose ni amide as a strong base. Naara Japon siya in solution. So mo bitaw na nga kasagara jud when you want to employ a reaction using a strong base, usually ginagamit jud is commonly kaning duha. This is hexane, and this one is tetrahydrofuran. Wala nga, mo gini mga common na solvent na ginagamit kung naatay very very strong base, because kani siya nga mga solvent is very difficult to deprotonate this one, and therefore solvent leveling effect can be avoided. Hexane, for example, and tetrahydrofuran, they have very large or very big pKa. It's very hard to deprotonate them. I tell you, that's why when you have strong bases like sodium amide, just dissolve them in hexane or tetrahydrofuran. Just use this in any of these two as a solvent, so that you will still retain the purpose of adding a very strong base in your reaction. But you just have to be very careful especially with tetrahydrofuran, because tetrahydrofuran kay kuan na siya kanang sa kind of solvent na kung magdugay na siya sa bottle, it will form peroxides which are very explosive. Yes, it could actually lead to explosions in the lab when you use tetrahydrofuran solvent can store siya for longer periods of time. That is why when you have THF, It is always accompanied by BHT, nakalimutan ko sa meaning, but it is actually a neutralizing agent for peroxides. It neutralizes peroxides or quench. It quenches the peroxides. Okay, actually, not just on the base when you put some strong bases. No, it is the leveling effect could also occur when you use strong acids. Like, of course, for example, you have when you react like sulfuric acid, for example, you react it with water as a reagent, and you have this compound. So this is hydronium ion, and this one is bisulfate ion. So same rin po siyang effect. Kung sa una, si hydroxide ion, which is the conjugate base of water, dili siya mosugot nga napay mas basic kaysa sa iya ha in solution. The same thing when you use water and you have strong acid. Ang conjugate acid, the water, which is the hydronium ion, okay, if we label this is the acid, and this is the conjugate base. This is the base, and this is the conjugate acid. Okay, so the same thing. Dili jud ni masugot ang solvent na naapay mas stronger na species kaysa sa iyang conjugate acid. Of course, it won't let that happen. That is why water would tend to like have this solvent leveling effect phenomenon to compensate or to hinder any strong acid na mas stronger pa sa iyahang conjugate acid. Okay, it's why when you have this kind of reaction in solution, though mas acidic pa si sulfuric acid kaysa sa kay hydronium ion, mas daghan jud o in terms of molecules, no, mas daghan jud o molecules, hydronium ions, rather not molecules, like ions in solution as compared sa sulfuric acid na compounds. Okay. Mas daghan gini siya in terms of number in solution. This is why you have this kind of, especially when you have strong acids, and makita ninyo sa mga books. For example, you have HCl and you react it with water. Always yun na siya nga, the equation would always lead to this kind of stuff plus H3O plus, because to water, di siya mo allow nga napay mas stronger na acid in solution kaysa sa iyang conjugate base. Mo-react din na siya sa acid, thereby permitting only its conjugate acid nga mas daghan pa kaysa sa HCl. Though mas stronger si HCl in terms of H3O plus, in terms of acidity, but i-prohibit ni water ang pagka-dominant ni HCl as a strong acid in solution. That's why it will react with HCl to allow its conjugate acid, which is H3O plus, to be greater in terms of number in solution. Mo nang tawag na solvent leveling effect. So it's very important that you know this kind of stuff. For example, so every time now you will do reactions and you need a strong acid or strong base is very crucial. It's very important rather when you do reactions and You always need this strong base or strong acid. It is very important that you should know which solvent ang imong gamiton. Kanay uban solvent, like for example, water, it will undergo solvent leveling and it will not allow anything na base na mas stronger pa kaysa sa iyang conjugate base. Also, the same thing is true when you have a strong acid in solution. Dili dyan na i-allow ng water na mas stronger pa ang acid kaysa sa ihang conjugate base. So inana si water ka as a solvent. So that's all about solvent leveling. In fact, this is just to introduce like which type of solvent should you use when you have strong acid or strong base.